of change in behaviors of graphs. Um, Whether you realize it or not, you probably already know how to do rate of change or average rate of change. If you hear that phrase, what you're finding is slope. So we found slope a lot in the last unit, which is if you recall, change in y over change in x, or the formula for slope is y2 minus y1 over x2 minus x1. So in the last unit, we just dealt with linear graphs or graphs of lines and did the slope. These won't always be linear, but you'll be finding the average rate of change, which is the same as finding the change from 2 points, y2 minus y1 over x2 minus x1. Now you might see it in function notation, but don't be scared by this because it's the same thing. If you see f of x2 minus f of x1 over x2 minus x1, that is still the exact same thing. Remember, this is function notation for y2, and this would be y1. So you're still doing y2 minus y1 over x2 minus x1. It's just different, written in a different way. So these two formulas are the same. Don't let the notation scare you. So what is different here is it's not going to say the word slope all the time. So be looking for keywords like rate of change, average rate of change. Examples of this would be a population of rats increasing by 40 rats per week. Ew, that's kind of nasty. The next one is a car traveling 68 miles per hour. So speed is an example of rate of change or slope. A car driving 27 miles per gallon of gasoline, or the amount of money in a college account decreasing by 4,000 per quarter. So all of those are talking about slope or the rate of change. So here it says use the data in the table below, find the average rate of change, which means we're going to find slope of the price of gasoline between 2007 and 2019. So I'm looking at these 2 points, and I'm going to do y2 minus y1 over x2 minus x1. So just depending on if you want to label this 0.1 and this 0.2, your y here, don't let it confuse you. They're using y as the year and c of y as your gasoline. So this is still going to be your input or your x1, and this will be your y1 when we're talking about the slope, and this would be x2, y2. So when you set this up, you're going to have $2.41 minus 2.84 over 2009 minus 2007. Now you notice that that is decreasing, so you're going to have a negative slope. So you're going to have negative 0.43 over 2, and when you plug that in, it's negative 0.215. So since we are talking about money here, we're going to round to the nearest cent, so that's approximately negative 0.22 dollars per year. So same thing, it might look a little scarier, the notation might be different, but it's asking you to find slope. So another way they can do it is give you an interval and a graph and say, find the average rate of change. So still I'm finding slope. Careful here, this is an interval. So these are both x coordinates. It's saying I'm going from -1, so here, which would be this point, to 2, which would be right here. So I'm talking about that point. So that gives me 2 points. I have one at -1, 4, and the other point is at 2, 1. So these are my x coordinates, my x1 and x2. And then the corresponding y's are my y1 and y2. Also notice I've got function notation. So using the same formula, that is the same thing as saying g of x2 minus g of x1 over x2 minus x1. So here, I'm still talking about y2 minus y1, and the bottom is the interval or the x coordinates. So I'm going to have 1 minus 4 over 2 minus a -1, which is going to give me -3. 2 minus a -1 will be 2 plus 1, which will give me 3 on the bottom. So I have -3 over 3, which is -1, is my average rate of change. So make sure you still need, even though it doesn't outright say it, you need 2 points from that information. So get your 2 points from your graph and plug that into your slope formula. Okay, let's look at finding average rate of change giving an equation. But notice here's our equation on the interval 2, 4. This is still our x1, x2. So how do I find my 2 points? Well, what you do is you plug those into your equation as f of x1, which in this case is f of 2. So everywhere I see an x in my equation, I'm going to plug in a 2. So I've got 2 squared minus 1 over 2, which will be 4 minus 1/2. Since I'm subtracting, I need to get a common denominator. So I'm going to put this over 1 and multiply top and bottom by 2 to get a common denominator of 2. So 4 is the same as 8 over 2, and then minus 1/2. So that's going to give me 7/2. So that is the point. I plugged in 2 and got out 7/2. And you can use 3.5 there if you want to. It's just if it's not a nice decimal, leave it as a fraction. So if it repeats, leave it as a fraction instead of changing it to a decimal. And then the next one, f of x2, because I still need my other point, I'm going to plug in 4 for x into my original equation. So I've got 4 squared minus 1 over 4. It's going to give me 16 minus 1/4. If I get a common denominator there, 16 would be 64 over 4 minus 1/4. So that'll give me 63 over 4. Now that's not going to be a nice number, so let's just leave it as a fraction also. Actually, it wouldn't be that bad, but I'll leave it as a fraction anyway. So now that was a lot of work, but I haven't answered the question yet. I need to find the slope because I'm looking for the average rate of change. So I've got f of x2 minus f of x1 over x2 minus x1. which is the same as y2 minus y1 over x2 minus x1. So here I've got 63 fourths minus 7 halves over, oh, and I made a mistake up here. This should be 4 because I plugged in 4 there, not 2. Some of y'all probably caught that and were screaming at me. But so there I've got 63 over 4 minus 7 over 2 divided by 4 minus 2. So if I change this to 14 fourths, so I have a common denominator, that's going to give me 49 fourths over 2. And here we're going to keep it, change it, flip it. So I got 49 fourths times, and when I flip the denominator, I got 1/2. So that's going to give me 49 over 8. So my average rate of change is 49 over 8. So here, don't be afraid if you're not super good with fractions to pull out your calculator and do some of this math just to check it. But it does help if you're good at adding, subtracting fractions. You can get your 2 points. And then when you divide, remember to keep it, change it to multiplication, and flip the bottom. And then you just multiply across. So 49 times 1 and 4 times 2 to get 49 eighths. And you can just leave it as an improper fraction like that. Okay, let's talk about behavior of graphs. That was all average rate of change. So don't be too scared about that. It's just finding slope. When we talk about behavior of functions, I'm talking about what's going on. Is it increasing, decreasing? Does it have a minimum or a maximum? So an increasing function is if f of b is greater than f of a. So remember, here I'm talking about y values for any input values where b is greater than a. So if I plug those in and the y values remain the same, greater than, the f of b is greater than f, then that means it's increasing. Decreasing is just the opposite. If f of b is less than f of a when b is greater than a, you've got a decreasing. So graphically, that's pretty easy to see here. Just like you're reading a book, if I start on the left side, if I was walking on this graph, I'd be walking uphill. So from here up until it starts to change direction, that is increasing. Once I start walking downhill, that's decreasing. And then when I start walking back uphill, that's increasing again. So when I say what parts of the graph are increasing, that's going to be from negative infinity until this point right here, which is going to be -2, and then unioned with 2 to infinity. Those are the increasing parts of the graph. Decreasing is going to be from -2 to 2. And notice I use parentheses on those because right at that point, your slope is 0 because it's changing from positive to negative right at that point. Here, it's changing from negative to positive right at that point. So the change isn't included into the increasing or decreasing part, which that brings us to local maximum and local minimum, which are considered local extrema. A local maximum is changing from increasing to decreasing. So basically, that's going to be a peak in your graph where you're changing from increasing to decreasing. So that's called a local maximum. I can't say it's the highest or lowest point of the whole graph because notice this one is going on forever and increasing forever. So there's not a absolute maximum, but there's a local maximum at the point -2, 16. So when it asks for the local maximum, it's asking for the y value. So you would say it has a local maximum of 16 at x equals -2. The local minimum is a change from decreasing to increasing, which in this case would be at 2, -16. So you'd say you have a local minimum of -16 at x equals 2. That's your local minimum and local maximum. Those both are called local extrema. So the minimum and the maximum are known as extrema. Now, when we talk about an absolute maximum or minimum, that means that's the absolute highest, the greatest value of a function over an interval. An absolute minimum is the smallest value of a function over an interval. So if we were looking at this previous graph, it doesn't have an absolute maximum or minimum because, like I said earlier, it's going to negative infinity and positive infinity. So it never reaches those points. So it has local max and min, but it doesn't have an absolute. But if it's on an interval, stress the interval part, the highest point or the highest y value, the greatest y value is your maximum, and the lowest or smallest value is your minimum. So here our absolute maximum would be at 2, and our absolute minimum would be at 0. So that's just kind of reading the graph, what's your absolute, the biggest and the smallest. Okay, let's look at a few more graphs. And here I'm going to ask you to analyze the graph. So when I say analyze, I want you to tell me where it's increasing, where it's decreasing, and if it has any local or absolute mins and maxes. So notice here, this one is going towards positive infinity and negative infinity. So it's not going to have a absolute maximum. It might have a absolute minimum, but not a maximum. So here we can, looking at the graph, if I was walking on the graph, I'm decreasing here, then I start going uphill, so I'm increasing, take a turn, go back down, and then increase again. So I'm decreasing, decreasing, increasing, decreasing, and then increasing again. So I'm increasing from here to here, and then again from here to here. So let's get all those points labeled. This point would be at 1, -1. This point would be at 3, 1. And this point would be at 4, let's say 4 and 3/4. It's a little over a half there, or 0.75. So we're going to be increasing on the interval from 1 to 3, and then again from 4 to infinity. We're decreasing from negative infinity to 1, and then again just a little bit from 3 to 4. So that's where we're increasing, decreasing. We've got a local minimum at 1, -1. So you'd say you have a local minimum of -1 at 1. And then we have another one at the 4 and 3/4. So you have a local minimum of -1 and 3/4 at 1 and 4, respectively. You have a local maximum at 3/1. So you have a maximum of 1, a local maximum at 1 at 3. You also would have an absolute minimum if you were just talking about the interval not going to infinity. You'd have an absolute min at 1, -1. On this next graph, you could do the same thing. You're increasing just on this part. So we're increasing from -1 to 1, and you're decreasing everywhere else. So from -infinity to -1, and then again from 1 to infinity. So you're decreasing on this part and this part. So you've got a local max here at 1, 2, and a local min at -1, -2. Okay, our last graph, we're going to say it's increasing here on this part. Notice we're on an interval. It's not going to infinity, but we still have an increasing part there and an increasing part here. So we're increasing from, that's about 2.5 or -2.5 to -2. And then union, we're also increasing from 0 to 2. So notice here, these look like points, but they're actually intervals. So know the context. I'm going from, this is an x value to another x value. And so that would make this x3 and x4. These are all x values, so it's an interval. I'm decreasing here from -2 to 0, and then again from 2 to 3. So decreasing from 2 to 0, unioned with 2 to 3. Now here, because it's on an interval, it's not going to -infinity or positive infinity. I've got local and absolute mins and maxes. So this would be a local max. This would be a local max. This would be a local min, because they're just changes in direction. But if we talk about absolute min and max, this endpoint would be your absolute minimum. And here, because these are at the same y value, there's no absolute maximum. So we do have an absolute minimum here, but not an absolute maximum, because they both at -2 and 2 are both at 16. So there's not one absolute maximum. So that's a little bit about analyzing graphs. I hope that helps with that homework. Please message me if you have any questions.